Hey everybody, today we'll do another problem, and today we will work on it's called implicit. It's called implicit differentiation, and again we'll come to the channel. We'll come to the new name, right? The same channel but with new name, Conservative Engineering Academy, right? And that is because I am a conservative engineer, so I want all my audience to know that, and whoever gets these videos with me, that I stand for conservative values, and of course, Jesus Christ is first, and then engineering, and then everything else after Jesus. That's my main focus in this channel, right? So here I am using this book, right? So I am using this book. I don't know, you can actually, the camera can see it, but it's called Calculus, a Classic Edition, right? So that's why I study when I taught calculus in college, and that's basically I'm using the same book, right? So let's do some example, right? So the book claims that first we will work it out on equation, right? It's not gonna be basically taking the derivative of the equation. It's just to see what the book says about implicit differentiation. It says, the book says, right? He says, we sometimes say that y is an implicit function of x, since we can write y equal f of x, right? So sometimes we say that y is an implicit function of x because we can write we can write this, right? We can write that y is equal to f of x, right? So if that is true, the book says, that means that we actually write implicitly, right? Implicitly. That's what the book is saying right here, that y can be written in a function can be written in this form, right? Okay, so let's see. Let's say that y the book says, let's say that y is equal to f of x, right? And then f of x is equal to 2x squared minus 3, right? So let's see if the book actually teaches something, right? So they say that this function, right, this y is equal to this function, and f of x, which is this, is equal to that, right? 2x squared, I think the book has, yes, it's x squared. Sorry, right? If you follow me, the example, you will, right? So, matter of fact, there's, like it says, 3.7, right? Chapter 3.7. Okay. So, that's it, right? That's what the books claim, that is an implicit, right? Implicit. Y is equal to f of x. Therefore, we can say that f of x is equal to x squared minus 3. Okay, and also the book is saying that in the same way, or in the same manner, we can claim that 4x squared minus 2y equals 6. The book is saying that these two equations are equivalent. Okay, let's test it out. Okay, let's say that we want to solve for y in this equation, right? So if y is equal, if f of x is equal to 2x squared minus 3, that means that y equal to 2x squared minus 3. So we agree that y is equal to f of x, so therefore this is the same as saying f of x is equal to 2x squared minus 3. Okay, so the books claim that this equation is the same. Okay, so how can we prove it? So I have to solve for y, right? In this case, y is already equal to 2x squared minus 3. In this case, I don't have that, I have an equation. So I have to solve for y. So therefore, I can add 2y on both sides, right? When I add 2y on both sides, I get what? I get 4x squared equal 6 plus 2y, right? Okay, now I need to solve for y, alright? So I still have to subtract x on this side. Subtract 6 on this side. So what I do x squared. Actually, you know what? Let me just do it step by step. So I subtract 6, right? And I subtract 6 on this side, right? Then I can say, okay, I can say 4x squared minus 6 equal to 2y, right? Okay, so if that is the case, I can actually bring this here, or, let me just bring it here. So I said that I still need to solve for y, so therefore, I have the equation of 4x squared minus 6 equal to 2y, right? Okay, so here what I can do is simply divide by 2 on both sides, right? In this case, I get what? I get, that is gone right there. Negative 6 divided by 2 is negative 3. And this goes into 4 2 times, so I get 2x squared minus 3 equal to y. Okay, so they are equivalent, right? So the book is saying that these two functions, the example that they're giving us, these two functions can be written explicitly, and they are equivalent to each other, right? Okay. So, with that being said, let's do an example. So, this is basically the algebraic type. The book is claiming that those functions, or that function was equivalent to the equation. So we proved that, right? So now we can do an example, and then we can actually eventually probably move on, right? So the book is saying the following. The book has a definition here that they claim that they have D, like that big D, and they say y to the n cannot equal ny to the n minus 1 unless, there's a word right here, unless y equal to x. Right? So, with that being said, let's do an example. Okay, so that is one of the statements, right? And the other statement that they have here is the following. They say that, dx, big D like that, y to the n equal n y to the n minus 1 and then they have the dy equal y to the n minus 1, y to the n minus 1, right? And then they say y prime, right? So basically what they say in here is that n minus 1, that can be equivalent to, and they have it right here, to, actually, they say that this can be written also as dy dx. And I was going to do that to explain it to you why they say in this, but they already did in this definition. So basically, I will just quick go through this. So basically, what they say is, if we take the derivative with respect to y, we can write it with dy dx like that, right? That's all they're saying. Okay, so let's do an example. Real quick. So remember that when we take the derivative of something, right? When we take the derivative of something, we always try to do with dy dx, right? Equal to such and such answer, right? So we will try to do the same thing in this example. Okay, let's do an example then. Let's do an example. Right? So let's do the example. Let's do an example. They say, for example, if we have y to the fourth, right? We have a y to the fourth, and then we have, so y to the fourth plus 3y, right? And then minus 4x cubed equal to 5x plus 1. So they want to find the derivative. They're telling us to find the derivative of this. Okay, first of all, here we will take the derivative on each term, right? So that means that we have to take the derivative of this term, that term, this term, this term, and this term, right? Okay, so remember here when we have a y, we actually will take the derivative with respect to y, right? But at the same time, we actually can, doesn't matter because we are going to take the derivative, so we will just do, with respect to x. Why not? Because technically y is always the independent variable, right? I'm sorry, y is the dependent variable, x is the independent variable. So we have to kind of take the derivative with respect to x, right? So let's do it. So let's do here. Let's do d x, right? And we do over here in parentheses we do y to the fourth, right? Like that, and then plus d, and then we do 3y, right? And then we do minus d and we do 4x squared, right? Actually cubed, right? And then, actually, you know what? Let me just work it to this corner right here, so I actually can fit everything on one line. Okay, so let's do it. So we say that d x y to the fourth plus d 3y, right? Plus, you can say plus or minus. If you say plus, then you have to put the minus inside the parentheses. So I always put like this: d minus, right? So the derivative of that, and then it's going to be that piece inside, which is going to be 3x cubed. And then here I will have a d and 5x and then plus d1. Alright? Okay, so if we do this, right? So if we take the derivative of this, right? So this one tells me that I have to take the derivative, right? but at the same time, I have to take the derivative of that, right? Of the y, right? So that's going to come to the front, that 4 will come to the front, and I get 4, right? I write y in there, and minus by 1 to the power, so it's y to the third, and I can say y prime, right? Then plus but remember that y prime is equal to dy dx, right? So this y prime is equal to dy dx. And then here, we take the derivative. Remember, this is the power of 1. If I take the derivative with the power of 1, it's basically 1 to the... So this is basically, because it's 1, so it's a power to the power of 1. So that means that if I take the derivative of that, it's going to be just dy dx, right? But remember, you're still keeping the 3. That is the kind of tricky part on this. I am still keeping the coefficient. So I will put 3 y prime, right? Because I take the derivative of that, right? So it's like saying y to the 1 power, right? Y to the 1 power minus 1, which is equal to y to the 0 power, right? And any number to the 0 power is equal to 1, right? So here, that's why I get that y prime, because that y prime here, y prime is equivalent to dy dx, right? So y prime is equal to, it's the same thing as saying dy dx, right? So let's get this problem finished up. All right. So I took the derivative of that, right? Now I will be taking the derivative of this. So the derivative of that, right, which is going to be what? It's going to be 12. It's going to be 12x. Remember, this is just x is dependent variable, right? That is independent variable. So I can actually just do 12x squared, right? And same thing here. I take the derivative of 5x, that just becomes 5, right? Right? And then I take the derivative of that one, it's just 0, right? So now my goals here, I already took the derivative. I need to kind of make it y primes equal to something, right? So what I can do, I can factor out y prime, factor out y prime, right? And say that 4y to the third, right, plus 3 equal to, and at the same time I can just add 12 here, right, 12x squared, 12x squared on both sides. So when I do that, I get what? When I do that, I get the following. When I do that, I get 12x squared, 12x squared plus 5. Right? Now, this is still this is still, I still have some piece right here that I need to move to the other side. So let me come to this board. And if we say that we have y prime, and we have a 4y to the third plus 3, right? And then we got that equals what? Equal 12x squared plus 5. Okay. So now I have, okay, so I need to solve, right? I need to solve for y prime. So now what I can do here, I can divide by 4y to the third, or y to the third, plus 3, right? And I can divide 4 by 4 y to the third plus 3. Alright, so this cancels out, right? They divide each other out. Now I have a y prime equal to what? Y prime is equal to 12x squared plus 5, right? Over 4y cubed plus 3. Now, what the book said is that if y, this is what the book said, right? So, this would be a good answer for like somebody who is asking you to take the differentiate this type of function, right? But the book went further, and they say that if y is equal to f of x, then we can write this function as follows. We can say y is equal to 12x squared plus 5, right? And we can say, okay, we can say 4, right? And I believe they put parentheses here like that, right? We can say that 4, let's see. Yeah. So we can say that 4, right? So we can say that this piece right here, right? So we can put parentheses around like that, right? And we can say that f of x, right? F of x cubed plus 3. And we close the parentheses, right? So we should have another set of parentheses here. I believe that the book has, yes, another set of parentheses right here. So, like that, right? And we have a 4 like this, right? So what they're saying is that actually this should be out. This should be out of parentheses. So what they're saying, like that, right? So what they're saying is that I have 3 y's or 3 functions to the power of 3 in here. Alright, and all this factor, 4 is multiplying those 3 functions to the third power and plus a constant, right? So that is the answer for this example. All right, so that is the answer for that example. I hope you learned something. If you learned something out of these videos, don't forget to give me a thumbs up and subscribe, share. Thank you for watching. Thank you for watching.